This is a screencast on the first section of the M3 Mechanics 3 part of the course, which is solving problems involving velocity, acceleration and displacement as they vary with time. To move through them, just the same as you did in M2, you take the derivative of displacement is velocity, the derivative of velocity is acceleration, the integral of velocity with respect to time is displacement, and the integral of acceleration with respect to time is velocity. So I'm going to start with a couple of examples that have been taken from the Heinemann textbook, and hopefully you'll see what I mean, see the pattern. So, question 1. Question 1 begins with a particle P is moving in a straight line. I'll let you read for yourselves. So, the acceleration is defined as 3e to the minus 0.25t meters per second squared. So, to get the velocity, we need to integrate with respect to t. Now, this is the integral, and when we set it up, we integrate it just as we would for a regular maths section. The only real difference here is that the integrals are a little bit trickier than they were in M2, but that's not much of a problem. So, the integral is this. Don't forget to add the constant because that's important. And then you get this as a simplified answer. Now, there were some initial conditions given in the question, and you can use those initial conditions to solve and find the constant. Okay, so that's what we've done here. I've plugged in the results. So the velocity is 4, the time is 0, and then moving through, we get that 4 is minus 12 plus c. Rearranging that, you just have that the constant of integration is 16. So the final answer for the velocity is minus 12e minus 0.25t plus 16. And it's important to not forget the units at the end. So we're dealing with velocity, so the units are meters per second. On to a slightly trickier question. That was question 1 of the first exercise, and now I'm going to jump all the way to question 12. Exactly the same approach. The only thing is the integrals are a little bit harder. Okay, so here's the question, and here's the idea. So part A, you need to find the acceleration from the velocity. You've got a condition here, and you need to find t. So dv by dt will give you A. So here's what we get. Okay, so remembering differentiating, this 2t just goes to 2, the log of t plus 2 goes to 1 over t plus 2, and the acceleration is equal to 2.2. I've done it quite briefly because it's quite an easy one, quite an easy question. So then you just solve it. Okay, take away 2 from both sides, take away 2 from here, and you're left with 1 over t plus 2 is 0.2. Moving the t plus 2 to the other side of the equation and multiplying both sides of the equation by 5 gives 5 is equal to t plus 2, and therefore t is equal to 3. Now the second part of the question is what makes it a little bit more difficult, but it's still quite doable. So the distance moved in an interval, so you need to integrate the velocity to give you displacement. And when you do that, you're then integrating between 1 and 4. So this is our integral here. So So we integrate with respect to t. Now, 2t, that integrates pretty easily, 2t squared over 2. This, a little bit more difficult, you need to do it by parts. So, just as a reminder, integral by parts, integral of u dv is equal to uv minus v du. Okay, I'm sure you already know that off by heart, and will never ever forget it. So the integral is the integral of log of t plus 2 is the one that we're doing, and if we split it, we can split it into 1 plus 1 multiplied by log of t plus 2 with respect to t. So dv here is 1 and du is log of t plus 2. So we carry on. T, log of t plus 2. Okay, this is our uv minus integral of v du. Okay, and this part here now needs to be split up a little bit. Okay, so it is a polynomial we can divide. Okay, so t divided by t plus 2 gives us 1 remainder minus 2, so we can split this into this, which then makes it integratable. So, moving on, this step carries down, and this now becomes the integral of this, thanks to that step there. So integrating further, we have integral of 1 becomes t, the integral of this becomes a log, and then just collecting some terms together just to tidy it up. We've got a minus t here, that stays there, and everything else is logs. So we've got a common t, we've got a common log of t plus 2, log of t plus 2, so we've got t and plus 2. So t plus 2 is the factorising of the log component. So, don't forget that we've got the original t squared term from earlier. That joins us again. Nice to see you again, hello. And then we've got the rest of the integral. And we're integrating between 4 and 1, so we substitute 4 in, we substitute 1 in. And that gives us these values here. And then just moving through this, and obviously you can move through this in your own time if you want to watch the video back or pause it. I've got 12 from 16 take away 4, and I've got 6 log of 6 from here, 1 take away 1, surprise surprise, 0, and then I've got a 3 log of 3, but because it's all take away, I've got minus 3 log of 3. Now I can combine those logs. I can say 6 log of 6 is 3 log of 6 squared by taking a factor of 2 here and squaring here. That gives me then 3 log of 3, and then I have 12, 3 log of 36 over 3. That simplifies just to make 12, and then I have the final answer, 12 is equal to 3 log of 12. Okay, and that is the answer to the question, how far does it move in between 1 and 4 seconds? That. Okay, I hope you found it understandable, and if you have any questions, try watching it through again, and obviously make sure you can follow the steps in the integrals. Thank you very much.